Yes?
Hello, Dr. Frizzle.
Good afternoon.
I have a patient with serious sunburns.
I'm afraid it's a serious case of ozone depletion. You should see my friends, Dr. Bryan Johnson and his coworker, Irina Petropavlovskikh.
Thank you, Doctor.
I work for NOAA, National Oceanic Atmospheric Administration, in an Earth Science Research Laboratory.
My name is Irina Petropavlovskikh. I'm a scientist and doing mostly research on the photochemistry in the atmosphere, trying to understand how sunlight affects the reactions in the atmosphere, and in particular how it changes the ozone.
Ozone it's one of the many gases that's in the atmosphere, but we call it a trace gas. It's made up of 3 oxygen atoms. Ozone's always around us. We're breathing it all the time, but very, very small amounts. And we can measure it with the instruments we have. This is the instrument that we launch in a balloon once every week here and send out supplies to different sites around the world, about 8 different sites. This is a weather radio sun that transmits the data back to a receiving station, so we get all the data while it's in flight, and this measures temperature and pressure. And this connects to the ozone sun, which is inside the styrofoam box. It protects it from the cold, and this is the instrument that actually samples the air and measures the ozone, and then sends the data back down from this device. So what I'm going to do now is just change, what we have to do is change these sensing solutions. That's how we measure ozone. We pump it into this little sensor. Ozone reacts with the potassium iodide salt that's in there. So we pull out the old solutions that have been sitting there for about a week. And then we add, it only takes 3 cc's or 3 milliliters of this potassium iodide salt solution, and the ozone reacts very quickly with that salt, and then generates a little electric current. But the current is very small; it's only a few microamps, but it's sensitive enough that we can take that information and make a good ozone measurement from that. So now it's all set, the solutions are in place, and it's ready to test out on the test unit.
I'm coming. So for 4 groups.
My name is Patrick Cullis, and I work in the Ozone and Water Vapor Lab for NOAA doing balloon launches. So we're doing our weekly ozone balloon here in Boulder. And, here's our balloon. I actually calibrate all of the instruments, and I also ship them out to the field sites. We have about 8 sites around the world. Mostly South Pole, Antarctica, and then we have a site up in Greenland on the top of the ice sheet, and then a couple sites here in the U.S.
Antenna that receives data from the ozone sun that we just sent up with the balloon.
But here's the data is actually coming in and going to a computer, and then it's updating on this computer screen here. So what we're getting is pressure and altitude that it's currently at, how fast it's going up, the rise rate, temperature, relative humidity, and here's the ozone showing up. Right now we're at 46 parts per billion at the altitude that it's currently at. And we'll get data every second as it's going up for the next hour and a half to 2 hours. So it's got a ways to go. It'll go all the way up to 32 kilometers, and it'll reach there in about an hour and a half. And then the balloon will burst, and then it'll come back down in a parachute. And we can pick up the data signal up to 100 miles away. So we'll track it all the way up and most of the way down. 32 kilometers. So it has a ways to go, about another hour and a half. It should reach its maximum altitude. So.
Ta-da!